Hey, Chan physics students, this is Mr. Block, and this is a quick video on how to complete the first graph on the graphing sheets that I gave you. So if you're online or you were absent, this is a video that you can watch where I'm going to do this first graph for you to remind you of all the things that we do for graphing. So go grab that sheet, and then what I've done here is I've just written in this open space just a real short way of putting those 6 things that we had in the presentation of what makes a good graph. So if you get a chance, maybe just pause this and write these things down for yourself as well. We're going to label X and Y. We're going to create a title. We'll scale X and Y. We'll plot the data, draw a trend line, and then complete the slope. So I'm going to do this first one. And I want you to know that every one of these things makes sense in the standpoint that if you do them in the right order, you won't mess anything up. And as I talk to you a little bit about it, you'll see what I mean. So the first thing we do is label X and Y. So we look at our directions. And so on our table here, they told us put time on the X-axis and distance on the Y. So if we then put time here on the X-axis, then we'll remember that that's the data that we're supposed to put on that side. And we'll put in the unit, and we'll see why we have to put in the unit later. All right, so then we're going to have distance on the Y. So we're going to put distance here to remind ourselves that this is the distance, and distance is in meters. Okay, so we've completed step 1. We've labeled these two. So the next thing is the title. So why do we have a title? Well, sometimes in books and in tests, sometimes they may not tell us what's here, but they will give us a title. And a title always tells us the same thing. It's the Y, so distance, versus the X, or time. And so if you just had the title, you should be able to know distance is here and time is here. Okay, so that's step 2. We're really doing well. That doesn't take very long. The next thing is the hardest thing. So I want you to listen to the way that I reason this out, okay, and I'm sure that you can use it to your advantage. When we put a scale on these two X and Y, we're just telling ourselves how much is every box going to be worth. And every box has to be worth the same. So the way that we do this is we say to ourselves, okay, what's supposed to be on the Y? Well, these numbers right here, all the way up to 32. So we know that there's a range between 0 and 32. We're not going to put these numbers here. We're just going to know that we have to get from here, 0, to somewhere up here, 32. And so since every box has to be worth the same, we can try to say, well, what about if we have every box be worth 1? So if I start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, eventually I'm going to see, right, that I'm not going to have enough room for 32. So 1s aren't going to work. How about 2s? And 2s do work. If I do 2, 4, 6, 8, 10, then right here, I know that I'm going to be ending at 30 somewhere over here. So that's what I'm going to do. 2, 4, 6. Okay, and so now I have a scale where every box is worth 2. And you see that even the first one, we go from 0 to 2, 2 to 4. Everything is just 2. All right, so now I'm going to do the same thing for the X one right here. And so we know that these are the numbers that are going to be needed to be put on there. And we're not going to put these numbers on, but we're going to definitely know that we're going to have to go from 0 to 60. All right. And so if I try 1s, well, every box worth 1 doesn't work. Every box worth 2, I'm going to run out of room. I'm not going to get up to 60, right? I go 2, 4, 6. You can see, right? I'm only going to get it to the 30s. So I go 1s, then I try 2s, and now I'm going to try 5s. And 5s are going to work. So 5, 10. You can see here on the X side, things are not as easy to write every number. So what I do is every now and then I just skip to 20, to 30. Now every box is still worth 5 when I skipped, right? The first one's worth 5, the next one is worth 5 to 10, but all I'm doing is making my numbers so that I don't fill them up so much that they're all crowded together. Okay. So now I've got a scale for each of the X and Y, and now I can start plotting my data. So before I do that, I just wanted to ask you guys, because we're always going to think now in physics, what is this? What are we graphing? And so when I look at this, I see, well, I'm looking at time and I'm looking at distance. So it looks like as time goes on, the distance gets further and further away. And what we're really looking at is a race. We're racing between a number of people. We're only going to be watching one of the participants. And the race starts at 0 and it ends at 32 meters. All right. And so we can imagine that there might be a person here that we're going to be watching racing, right? And as the person races, the students who are taking the data say, okay, at 0, that person's at a certain spot. At 10, they're at a certain spot. Well, what we're really doing, though, we need to look at, well, what's going on here at the beginning? How can someone start a race at 0 seconds and be at 5 meters already? And what I have been telling the students in class is it must be that your little brother or your little sister is going to join you in this race. And we're going to give them a head start. We're going to put them at the 5 meters. We're going to give them a 5-meter head start. And that's the person we're going to be watching. So at 0 time, this person's at 5. And in 10 seconds later, this person's here and they're at 9.5. And then 10 seconds later, again, we take the data and we find out how far they are, okay? So that's what we're looking at. And I will always want you to think about graphs that way. What are we graphing? Not just numbers and columns and stuff. It should make sense to us that we're graphing something. All right, so plot the data. So whenever you talk about a plot, like a plot of land, we can think of people going out in the west and maybe putting a stake down and then driving or riding their horse, 100 acres one way and putting on another stake, and they're making a plot. They're putting down a stake. And so plotting just simply means to put a dot down in a certain spot. And so what we're doing here when we plot our data is just say, okay, let's look at this first one, which is 0 and 5, and let's find where that is on our new scaled graph. So 0 on the x-axis is right here, and up to 5 right there. And so our first dot goes at 0 at 5. That's where that one goes. And the next one is at 10 and 9.5, which is right there. And the next one's at 20 and 14. So we should go right there. All right, and then I'll just put the rest of these in. 30 and 18.5 right there. 40 and 23. And then we see that there's 2 for 50. And the way I was telling kids in class is for 2 people at 50, it must be that the kids said, wait a second, one person got this data, one person got that data, or they thought that they made a mistake and so they retook the data. But you can see what happens here at 50 and 24.5, there's a point right there. And at 50 and 27.5, well, there's a point right here. And so what obvious was that the kids saw that the graph was going perfectly up a line until this next dot here, and they said, oh, I made a mistake. And so they took the data again. And then 60 is at 32, right there. Okay, so now we've done step 4, plotted our data, right? We've got all of these simple data points, and we've got them in one spot. And so now what we have to do is draw a trend line. And so what I told all the students is trend line is not connecting these dots like that. That's not a line, right? That's just connecting the dots. A trend line, we use a ruler. And what we do is we try to get all or as many of our dots on the same line as we can. And you can see how that one dot is really going to throw us off a little bit. So we could try our best to get really, really close to all of these and include just a little bit of that one dot that's there. Or we might just say, you know what, that one must be a mistake. And let's get all of these other ones, since they're perfectly on the same line. Let's get them all on the line. All right, take a pencil, we draw our line all the way up like that, and that's our trend line. Okay. So what is our trend line? It's an average of all of these points. It will average out any of our mistakes. And the last thing is slope. And a lot of people, they learned slope as slope equals y2 minus y1 over x2 minus x1. And I can just tell you right now, right, that's perfectly right. Always right. But the problem that we have is that then your first inclination is to go and try to find points from here and use them to find your slope. And that is not correct, because in science, most of the time our points won't be on the line. And so if you accidentally, let's say, have used this in your calculation, so if you use this point, then you're not going to get the slope of this line. You're going to get the slope of some other line that includes that point. So let's learn a different way that we can use in science that is always going to work. Okay? And that is, if we look, slope, well, first of all, what is slope? What does that word mean? If you're walking up a mountain, you're saying, oh, this is a steep slope, meaning that you're going up really, really fast, right? So a steep slope looks like this. But a gradual slope or a low slope, well, that's going to look like that, right? And so slope is just the same as that on the graph as we might talk about it. And slope is just how fast the line is rising, okay? And as I get further and further right up, it's rising more than it's going this way. And so another way to look at slope is to calculate what's its rise divided by its run. So slope equals rise over run. And what makes this method a little bit easier for us in science is that then we can focus on the line instead of points. And what I mean by that is we just need to find 2 points on the line that we can use to find rise over run. How do we do that? Well, first I just take my hand and I start going up this line, okay? And I'm looking for a time when the pencil line that I put on goes exactly next to one of the grids. And you see how they're kind of off, 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 off until I get right here. And I'm going to put a circle in there. Okay? Right there, the line goes right through the grid lines. Okay? And it's going to make my life real easy to find slope if I can use that point. Now I'm going to keep going up to find another one. So if I go up and I'm going to find another one where this happens again, and sometimes I like to go all the way up to here, right? Okay, where I find it again. All right. And unfortunately, I just put this in here, but we're going to do something now, and that is we're going to find our 2 points, and then we're just going to draw pictorially our rise. So our rise is right up this line until we're even, like that. And our run is like that. All right, so you can see, right? Between these 2 points, I rose this far, and I ran, meaning go this way, I ran this far. Okay? And now my goal is real simple. I need to find out how far did I rise and how far did I run. And so when I look at this, I go, well, I'm starting at 16 and I'm going up to 36, right? So I had to go 34, 36, right? So 16 to 36, what's my rise? 20. And I just put that number right there. And now I'm going to run. And so when I look at my run, I'm starting at 25 and I'm ending right here at 70. Okay, so here's my run. I start at 25. I'm ending at 70. And so my run is 45. All right. So now I've got the beginnings of slope. I can just go rise is 20 and run is 45. But 20 what? 20 meters. And so 20 meters divided by 45 what? Well, 45 seconds. And so we get this unique answer, 20 divided by 45. And if I open up my calculator on my phone or just grab one, I think we're going to see a number about 0.45. So 20, apparently my phone has got a lot going on here. 20 divided by 45 is 0.44. 0.44. All right, 0.44 what? Meters per second. So the last thing is, what does that mean? Meters, 0.44 meters per second. Well, just like miles per hour, meters per second must be a velocity. And so what we've done here, when we look back at our picture, is that we must have found the velocity of our little brother. He runs at 0.44 meters per second. And you can take an attempt at it, but 0.44 meters per second is quite slow. All right. If you have any questions, always come ask me, but I hope this video helps you. When you do the next graph, right, you're going to see that the y-axis is really easy to scale, but the x is really difficult. There's a lot of numbers here, right? And so as I told everybody, what you should do when you're doing this one is cheat, and that is cover up all those numbers. And now we can see that our number goes from 0, somewhere up here, to 0.08, 0.11, 0.15. And so we need to get up to 0.37. Now, can we go by 0.1s or 0.01s? No, we don't have 37. But we can go by 0.02s. So try 0.02s to do that. And then remember that your job will be on the back side to watch a video of me doing a car video on a track. You'll get more data. You'll create your X and Y, all right, and you'll find your slope. And then you'll answer these questions. And I'll just give you one last hint, and that is when you get to the last question, how long, make sure you remember that you'll have the 4-column method. They're going to give you a distance of 200 centimeters. You're going to know your velocity because you'll know your slope from here, and they'll ask you to find your time. So you'll know this number from the graph, and then you can use your 4-column method to find the time. Hope this helps you. Sorry for being so long.